Before I can graph one period of this tangent function, I'm going to need to analyze it. And so looking at this equation, there's a few things that I can note right away. Since the a value is negative, this graph is going to be reflected. So I'll make a note of that to keep that in mind when I graph this in a minute. I can see because I have a plus or sometimes a subtraction number at the end here, that's going to be moving your midline up and down. So that's going to move my whole graph up one, so every space will be moved up one space. Tangent graphs don't have an amplitude, so we're not going to list that, although 3 will be significant when I graph this in a moment. And then I guess the last thing I can find out with this is the period. Now recall that the period for a tangent graph is just pi divided by b, not 2 pi divided by b, like sine and cosine. So pi divided by the b value, which is 1/2, gets me a period of 2 pi. So with all those facts and figures in mind, I'm ready to graph one period of this. So recall that a tangent graph is kind of evenly split to the left and right of the origin. So I'll go ahead and start my graph like that. For my x-axis numbers then, normally when we did sine and cosine, we were just putting the period down there. Well, since this graph is split, half on the right and half on the left, I want to go ahead and make sure my period is split between that as well. And so instead of going 2 pi on both ends, I'm going to split that in half and say negative 1 pi and 1 pi over here. The total distance then between those two values is 2 pi, which is the period. What's going on at those two locations, though, are not points. Those are actually the asymptotes. So I'll go ahead and draw in a couple dashed lines there to indicate the asymptotes of this function. At least 2 of them. Those will go on forever and forever. Also then I'm going to want half of that distance. So I split the period in half to get these values. I'll split the period in half again to get these tick marks on my x-axis. So half of 1 pi is going to be a half pi, and then negative half pi over here. And then let's see, next thing I'll do is I'm going to label my y-axis. Well, recall that everything had been moved up 1 in this graph. So normally we had that point at 0, 0, not anymore. This time that graph is going to be moved up 1 space, so I'll label that. And then from there, now is when I'll finally use that a value, that 3. It's not an amplitude, but it's significant to my graph. So from that midline, that up 1, I'm going to go up another 3. So 2, 3, 4, I'll label that, and then down 3, so 1, 2, 3, so negative 2 down there. Using those values then, those tick marks, I can go ahead and get a graph of this tangent wave. Also recall that we're reflected this time. So my first point would be right there at 0, 1 this time, no longer 0, 0. And then normally our pattern went something like that, but because we're reflected, things are different this time. So I'm going to actually be up here. Negative 1/2 pi comma 4 would be a point. And then if I go over 1/2 pi and down negative 2, that will also be a point. Now I know my directions said graph this using 5 key points. We're going to call the asymptotes a couple of the points. So maybe I'll put points in quotes. Okay, anyway, to finish this one then, let's go ahead and get that tangent wave drawn in here. Looks like I'm going to have to draw over my words a little bit there. Oops. And then we'll get closer and closer to those asymptotes and then not quite touch them. I missed the point down here, so what I always do, just make the point bigger and look, no one can tell. Oops, I missed that one too. Hopefully your graph turned out better than mine, but there you go. Let's just make that asymptote a little bit higher. There you go. There's one period of this tangent wave with all our key values labeled.